I want you to picture a small city. It's got a population of maybe 30 or 40,000 people. It has its own power plant, a massive police force, high-density housing blocks, major sports stadiums, and
And arguably the highest concentration of hazardous chemicals and nuclear research materials in the entire region.
right, exactly.
Just to make it a little more interesting, let's populate this city almost entirely with young adults who are, living away from home for the very first time.
Yeah, brains that aren't quite fully formed yet, making high-risk decisions on very little sleep.
It's quite the combination.
It really is. We are talking, of course, about the modern university campus. On paper, it sounds like a recipe for absolute disaster, doesn't it?
It absolutely should be. I mean, if you pitched this concept to an insurance company without any context, they'd laugh you right out of the room.
But somehow, it works. Most of the time, these places run like clockwork. And today, on this deep dive, we're going to figure out how. We've come through a massive stack of documents, everything from the AUCSO 2025 benchmarking report to the official Incident Command System training manuals.
Right, plus those specific emergency guides from places like UCSD, Loyola, and Thomas Jefferson University.
Yeah, exactly. It's a fascinating look at how these institutions prepare for and manage chaos. We're going to break down how campus security has completely evolved from the old days of gates and guards to what they're calling all hazards management.
And by the end of this, you're going to know exactly why you should never use a cell phone during a gas leak.
Oh man, that part blew my mind. Plus, we'll get into what ignition control means and why something called the 18-inch rule might literally save a building.
It's a lot of ground to cover. We're looking at a field called higher education emergency management, and frankly, the deeper you get into these source documents, the more you realize that security isn't really the right word for it anymore.
Yeah, what was the term they kept using?
Integrated resilience. That's the industry term that's really shifting into focus right now.
Integrated resilience. Okay, it sounds very corporate, very fancy, but what does that actually look like on the ground? Because when I think of campus security, I still have this mental image of like a guy in a windbreaker with a flashlight checking to see if the library door is locked.
Right, the classic gates and guards model. And that was the standard for decades. It was purely about physical barriers. But the AUCSO report, that's the Association of University Chief Security Officers, they make it incredibly clear that that model is effectively dead.
Is that just because the threats have changed over the years?
Well, the threats have definitely changed, but the expectations have changed even more. The report highlights this whole concept called beyond guarding.
Beyond guarding.
Yeah. Think about it. If a student is having a mental health crisis at 2 in the morning in a dorm, or if there's a welfare concern because someone hasn't been seen in 3 days, who is the first person on the scene?
It's almost always campus security.
Exactly. So suddenly, you don't just need a guard who knows how to use a padlock. You need a first responder who's trained in de-escalation, in mental health first aid, and in student welfare.
So they're essentially part of the university's care network now.
They are. The job description has completely expanded.
Now, that is a massive shift in responsibility. And there was a statistic in that AUCSO report that really jumped out at me regarding this shift. It mentioned that despite this move toward care-based security, the workforce is still incredibly homogenous.
The diversity gap. Yeah, this is a major, major point in the benchmarking report. Women make up only about 5% of the security workforce in these institutions.
5%. I mean, that seems remarkably low for a modern university environment.
It really is. And the report argues that if your security team is supposed to be the front line for student welfare, well, it creates a pretty significant barrier if that team doesn't reflect the community it serves.
Right. If a female student is in distress, she might not feel entirely comfortable opening her door to a team of all men at 2 a.m.
Precisely. So there's this massive push right now for professionalization, targeted recruitment, career pathways, better pay all, to try and fix that balance and bring the human element up to speed.
Okay, so you have the human element shifting. But then I was looking at the tech sources we gathered, specifically those papers from Centegix and Volt, and it feels like the technology is getting, well, aggressive? We aren't just putting cameras in hallways anymore.
Oh no, we are firmly entering the era of the force multiplier.
Force multiplier. How are they defining that in this context?
It's originally military terminology. It essentially means using technology to let a very small team cover a massive area effectively.
Because if you have a campus of 2,000 acres, you obviously can't have a guard standing on every corner.
Right. And the standout example here in the documents is the wearable panic button.
This is primarily for staff and faculty, right?
Yes, so in the old days, if a professor had a hostile student in their office or a lab assistant saw a fire break out, they had to find a wall phone or fumble around in their pocket for their cell phone to call safety services.
And let's be honest, in a blind panic, unlocking your phone and dialing a 10-digit number is way harder than it sounds.
Yeah.
Your hands are shaking, you drop it.
Exactly. You lose precious time. The new standard described in the scientific source is a badge or a fob that sits right on a lanyard around your neck. You just press it.
And it calls them.
Better than that. It doesn't just send an alarm, it sends your precise geolocation directly to the security dispatch. It cuts the response time down from minutes to seconds.
Wow. Now, the other tech piece that felt a little sci-fi to me was the AI integration in the cameras.
Yeah, that's a controversial one, but it is fast becoming the standard. It's not just passively recording for evidence after a crime happens anymore. The AI is analyzing the video feed in real time. It can flag what they call unusual crowd dynamic.
Unusual crowd dynamics. What does that actually mean in practice?
Imagine a really busy campus plaza. Everyone is just walking randomly, going to class. Suddenly, 50 people start running in the exact same direction.
Uh-huh.
The AI recognizes that sudden pattern as a threat response. It immediately alerts the command center before a single person even thinks to dial 911. Or in some cases, it can visually detect a weapon before it's even fully drawn.
So it completely shifts the focus from investigating an event to interrupting an event.
That is the ultimate goal, stopping the event while it's happening. But there is a huge catch mentioned in the sources, and it's the problem of siloed procurement.
Siloed procurement. That sounds like classic corporate speak for we didn't talk to each other.
That is exactly what it is. You have the security department over here buying these fancy new AI cameras, and then the facilities department is off buying new smart locks, and the IT department is buying servers.
And none of the systems talk to each other.
Exactly. The deep dive material emphasizes that for this whole integrated resilience thing to actually work, you need one unified tech strategy. It all has to connect.
Okay, so we've got the people and we've got the tech. But you can't run a city or a campus without a system. And this is where the source documents got really dense. I spent a lot of time trying to wrap my head around the ICS.
Ah, the incident command system.
It's literally everywhere.
Yeah.
From a university in North Dakota to one in San Diego, they all seem to use this exact same flowchart. Why is it so rigid?
Because chaos is the ultimate enemy in an emergency. ICS was actually developed back in the 1970s after a series of just disastrous wildfires in California.
Really? I didn't know that.
Yeah, they did postmortems on those fires and realized the problem wasn't a lack of resources. The problem was that different agencies, the fire department, the police, forestry, they couldn't talk to each other. They literally didn't speak the same tactical language.
So ICS is basically a universal translator for emergencies.
In a way, yes. It provides a standardized hierarchy so everyone knows their role instantly. And the most important rule in the whole system, and the one that honestly saves the most lives, is unity of command.
Meaning what exactly?
Meaning that no matter who you are, whether you're a police chief, a dean of students, or a janitor in an emergency, you report to one person. You never, ever have two bosses.
Because if you have two people shouting conflicting orders, people just freeze.
Exactly, and freezing kills.
So who sits at the very top of that pyramid?
That would be the incident commander. They run the entire show. But, and this is a key takeaway from the manuals, they don't do everything. If the commander is out there trying to hand out water bottles to responders, they aren't commanding.
Right, they lose the big picture.
Exactly. So they have a command staff to handle all the specific headaches.
I saw three main roles listed there. There was the public information officer, the liaison, and the safety officer.
And those are crucial roles. The public information officer or the PIO, they are the single voice to the outside world. If you don't feed the media and the students accurate information immediately, rumors just fill the void.
And on a college campus, rumors travel faster than light.
Absolutely. Then you have the liaison officer.
They're essentially the diplomat, right?
Exactly. They talk to the external agencies, the fire department, the Red Cross, the FBI, whoever shows up to help. Having one person manage those relationships frees up the commander to just focus on strategy.
Now, the third role, the safety officer. They seem to have a frightening amount of power in the descriptions.
Oh, they hold the veto card? The safety officer is the only person in the entire structure who can completely bypass the commander.
Really? The only one?
Yes. If they see a wall about to collapse or a toxic gas cloud shifting toward the rescue teams, they can yell stop. and the entire operation halts immediately. There is no debate.
Wow. That's a vital check and balance. Now, below that command staff, you have the general staff. The training manuals broke this down into 4 sections, but I actually found a note in the margins of one guide that described them simply as the doers, the thinkers, the getters, and the payers.
Honestly, that is the best possible way to remember it.
So the doers are operations.
Right. Operations is the verbs. They fight the fire, they barricade the door, they triage the wounded. They are the ones out there getting dirty.
And the thinkers would be planning.
Planning is looking into the future. Operations is fighting the fire right now. Planning is sitting back and asking, what happens in 4 hours when night falls? Do we have lights? What if the wind shifts? Who is relieving the firefighters who are exhausted? They write the actual incident action plan.
Then you have the getters, which is logistics.
Which is my favorite section. There's a saying, amateurs talk strategy, professionals talk logistics.
Right.
If operations needs 500 sandwiches, 3 generators, and a specialized chemical neutralizer, logistics has to find it, buy it, and get it to the scene. If logistics fails, the whole operation starves, literally and figuratively.
And finally, the payers. Finance.
It sounds so boring, but someone has to track the hours, handle the insurance claims, and sign the emergency contracts. If you don't track the costs properly, the university might go bankrupt just trying to survive the fire.
There was one other management concept in those ICS documents that really stood out, and I think it applies to anyone managing a team, even completely outside of a crisis: span of control.
Oh, absolutely. It's the idea that the human brain has a hard biological limit on how many people it can effectively supervise in a high-stress environment.
What's the magic number they use?
Ideally, it's 5. The acceptable range is 3 to 7. If you are an incident commander and you have 15 people reporting directly to you, you are failing. You will miss critical information.
So what do you do with those 15 people?
You break them down. You divide those 15 people into 3 groups of 5, appoint 3 leaders, and just have those 3 leaders report to you.
So it's modular management. It expands and contracts as the crisis grows.
Precisely. It keeps the communication lines clean.
Okay, so we understand the overall structure now. Now I want to get into the specific threats, because this is where the integrated global frameworks and the university guides gave me some serious anxiety. Let's start with fire, but not just a normal dorm fire, a fire in a science lab.
Oh, labs are absolute nightmares for firefighters. You have compressed gases, oxidizers, biological agents. The protocol is completely different from a standard building fire.
I learned a new phrase here: the incipient stage.
It's a crucial concept. The manuals tell you that you should only try to use a fire extinguisher if the fire is in the incipient stage.
Which means?
It means it's small, like the size of a standard office trash can. And it hasn't started to spread or produce massive amounts of thick smoke yet.
So if the flames are hitting the ceiling, don't try to be a hero.
If the flames are hitting the ceiling, you run, period. But in a science lab, you can't just run out the door. You have to execute a shutdown protocol before you go.
And this involved the fume hoods, right?
Yeah.
I never really understood what those glass boxes were actually for until I read this section.
They are your primary line of defense. If you have a chemical fire, the toxic fumes can actually be much more deadly than the heat. If you run out of the room and leave the fume hood sash open, those vapors just flood out into the hallway where everyone else is trying to evacuate.
Oh, wow.
You have to pull the sash down. It contains the fumes, and it cuts off the oxygen to the fire.
There was a specific note about cryogenics, too.
Right. Universities have incredibly specialized equipment that can't just be unplugged. Superconducting magnets, biological incubators holding decades of research samples. You can't just hit a massive kill switch for the whole building.
Because it would ruin everything.
Exactly. So the guides talk about achieving a minimal safe state. You have to secure the hazardous materials so they don't become a bomb, even if the power goes out completely.
Speaking of things hitting the ceiling, I need to ask you about the 18-inch rule. I read this in the fire safety codes, and I immediately looked at the top of my own bookshelf and felt deeply guilty.
Everyone violates this one. The rule is simple: no storage of any kind within 18 inches of the ceiling.
Is that just so the fire doesn't have a bridge to jump to the roof?
It's actually entirely about the sprinklers. Think about how a fire sprinkler head works. It doesn't shoot water straight down like a shower head. It sprays outward in a wide umbrella pattern to cover the whole room.
Right, okay.
If you have cardboard boxes stacked all the way up to the ceiling, they block that horizontal spray. You create a shadow or a completely dry zone right behind those boxes.
Oh, I see.
A fire can start in that dry zone, grow massive, and the water never even touches it. You've effectively defeated your own sprinkler system.
So my hoarding of old tax documents up on the top shelf could literally burn the building down. Good to know. Well, let's pivot to the threat that actually scared me the most in these documents. Gas leaks.
Gas is terrifying, mostly because it's invisible. You rely entirely on that rotten egg smell, which, by the way, isn't actually the gas itself.
Right, the gas is odorless, the smell is an additive, methanethiol.
Yeah, they put in there so you notice the leak. But the integrated global frameworks highlighted a concept here called ignition control. And I bet 90% of people get this wrong.
I know, I definitely would have. Let's do a scenario. I walk into a basement and I smell really strong gas. My absolute first instinct is to pull out my cell phone to call 911 or maybe flip the light switch to see where the leak is coming from.
And if you do either of those things, you could blow up the entire building.
Just because of the phone.
Yes. Natural gas ignites at around 1200 degrees Fahrenheit. Now, that sounds incredibly high, but the energy needed to trigger that ignition is microscopic.
How microscopic.
The tiny electrical arc inside a light switch when you toggle it, or the battery connection when your screen suddenly lights up on your phone, that tiny spark is enough to ignite the gas in the room.
So the protocol is
Don't.
do nothing.
The protocol is don't touch anything. Don't touch the light switches. Don't touch the elevator buttons. Don't even touch the fire alarm pulse station on the wall.
Wait, don't pull the fire alarm.
No, it sends an electrical pulse. You just turn around, hold your breath, and walk out. And you just keep walking.
And the evacuation distance for gas was huge, too. I mean, for a standard fire drill, you usually go out to the parking lot maybe 200 feet away.
For a suspected gas leak, the blast radius is your main concern. The guidance says 1,000 feet minimum. And ideally, you need to be upwind. You need to be blocks away, not just standing across the street taking a video.
That is a highly specific, actionable tip that I am absolutely never going to forget. 1,000 feet, and do not touch your phone. Got it. Now, living on the West Coast, we definitely have to talk about earthquakes. The UCSD guide had some intense myth-busting on this topic.
We really have to talk about the running outside myth. You see it in every single disaster movie. The ground starts shaking and everyone instantly sprints out the front doors.
Is that not exactly what you're supposed to do? Get away from the giant building that might fall on your head?
Statistically speaking, that is exactly how you get killed. In a modern country with proper building codes, the building itself probably won't collapse, but the facade absolutely will.
A facade? Like the decorations?
Gargoyles, glass panels, bricks, heavy signage, that stuff shears right off the exterior and falls straight down into the street below.
Right into the kill zone.
Exactly. If you run outside during the shaking, you are literally running into a rain of bricks. You stay inside, duck, cover, and hold on.
But once the shaking eventually stops, then you leave, right?
Not necessarily, and this was a huge surprise in the documents. You only evacuate after an earthquake if there is a secondary hazard.
Meaning things like a fire starting or a gas smell?
Right. Or if there's very visible structural damage. If the interior walls are violently cracked or the sprinklers are going off, yes, you leave. But if the shaking stops and the building seems totally fine, you stay put.
Why?
Because you don't want to flood the chaotic, dangerous streets unless you absolutely have to. Let the responders assess the area first.
And if you do have to leave, I noticed the guide specifically said to take your keys and your wallet.
That is the voice of hard-earned experience right there. If a building gets red tagged by the structural engineers.
That's part of the ATC 20 standard, right?
Yes. ATC 20 uses colored placards. Green is good, yellow is restricted, and a red tag means unsafe. Do not enter under any circumstances. If your dorm or your office gets red tagged, you might not be allowed back inside for 6 weeks.
Wow.
If your car keys and your ID are sitting on your desk in there, you are stranded, so grab your essentials on the way out.
This leads really nicely into the human side of all this planning. We can have all these rigid rules about 1,000-foot perimeters and red tags, but not everyone can just sprint out of a building. The Loyola University documents were really strong on the topic of inclusivity.
They talk extensively about moving from what used to be called special needs planning to the concept of universal safety.
Universal safety.
Yeah. The reality is, in a major emergency, anyone could suddenly have a limitation. Maybe you broke your leg skiing last weekend, or you lost your glasses in the smoke, or you're just having a severe panic attack. It's not just about permanent disabilities.
I've seen those signs for areas of refuge near stairwells and elevators. I always just assumed those were like waiting rooms.
They are life-saving bunkers. Elevators automatically shut down during fire alarms. So if you are a wheelchair user on the fourth floor, you obviously can't use the stairs. An area of refuge is a specially fire-rated space. Usually it's a stairwell landing with extra heavy doors where you can wait safely for professional fire rescue.
Do the responders just know to check there?
Well, it also has a dedicated hardwired intercom system, so you can tell the command post exactly where you are.
The guide was also incredibly explicit about how to help, or actually how not to help wheelchair users. It specifically said, do not carry them.
Yes. Unless it is literally a life or death situation, like the flames are actively inside the room with you, do not ever try to carry someone down the stairs.
Why is that? Honestly, it seems like the noble, nice thing to do in a crisis.
It's dangerous physics. Carrying a full-grown adult down narrow, crowded, smoke-filled stairs without their specialized chair is a recipe for dropping them. You risk causing a catastrophic spinal injury to them or blowing out your own back and effectively blocking the only exit for everyone else.
So what's the actual protocol?
The protocol is get them to the area of refuge, ensure they are safe there, and notify the command post immediately so trained professionals with the right equipment can extract them.
The documents also heavily emphasize something called the buddy system to help manage this.
Right. If you have a known disability, you really shouldn't have to rely on random strangers in a panic. The buddy system means you pre-assign a colleague or a friend who knows your specific plan.
And their job is just to execute that plan with you.
Exactly. Their job isn't to physically carry you, but to ensure you get to that refuge area calmly and that the responders are notified right away.
There were also some really helpful interaction protocols in there for helping people with sensory impairments.
Simple things that you completely forget when your adrenaline is spiking. For example, if someone is visually impaired, don't just run up and grab their arm and start pulling them. It's incredibly disorienting and scary.
You offer your arm instead.
Yes, offer your arm. Let them hold on to you. You become the guide, not the captor. Describe the obstacles as you move.
And for someone who is deaf or hard of hearing,
Don't scream at them. If the power is out, it's dark, they can't hear you, and they can't see you scream. The tip there is to shine a flashlight on your own face, not theirs.
oh, so they can read your lips.
Exactly. Shine it on yourself so they can read your lips and see your facial expressions.
That is such a small detail, putting the flashlight on your own face, but it changes the entire dynamic.
That is the real nuance of universal safety. It's about empathy in a crisis.
So we have the management structure, we have the specific hazard threats, and we have the inclusivity protocols. But none of this works in reality if people don't practice. And this brings us to the final piece, the culture of preparedness.
Drills. Everyone groans when they hear the word. But the research shows they are utterly vital if and only if they are done correctly.
The sources mentioned moving away from trauma-inducing drills and shifting toward data-driven drills.
Yeah, deliberately scaring people doesn't teach them anything useful. You want to build muscle memory, not panic. And you want to actively measure how the system performs. Don't just ask a binary question like, did we get out? Ask, how long exactly did it take for the emergency alert to hit everyone's phone?
Right, they called that the alert dissemination time,
Yes. And you also measure egress efficiency.
which means looking at how people actually leave the building.
Right. Did everyone creatively use the side and back exits? Or did we have a massive, dangerous crush of bodies at the main front door? If 90% of people tried to go out one single door, the drill failed, even if everyone technically made it outside.
They're essentially KPIs for survival.
Exactly. If you measure it, you can improve it.
The other big cultural takeaway was treating the students as partners in all this, not just as cargo to be moved around.
Students are smart. If you actually tell them why they need to close the door behind them to stop the toxic smoke spread, they will do it. If you just treat them like cattle to be herded out of a building, they'll ignore you. The ultimate goal is building an all-hazards mindset.
Because you can't write a specific script for every possible disaster in the universe.
You really can't. But if you have a highly flexible management system and a properly educated campus population, you can handle whatever comes at you, whether that's a blizzard, a chemical spill, or a massive power outage.
It's really about building a completely resilient ecosystem. Well, we've covered a huge amount of ground today, from the high-level management strategies of the incident command system.
Down to the granular physics of exactly why you don't touch a light switch during a gas leak.
It puts a whole new perspective on those boring orientation sessions we all had to sit through back in the day.
It really does. It reframes the campus from being a potentially scary place into a highly managed, resilient place.
So to wrap this up, I want to leave you, the listener, with a thought from the fire safety section we reviewed earlier. It talked about the concept of the safe fire.
Right. The safest fire is always the one that never actually happens. It's the fire that was prevented by boring, everyday housekeeping.
So here is your challenge for today. When you finish listening to this, look around your office, your dorm room, or even your garage at home. Look up at the ceiling.
Check that clearance space.
Do you pass the 18-inch rule? Or is that giant stack of boxes creating a dry zone that could compromise your entire building safety system? It takes maybe 5 seconds to check, but as we learned today, those inches really matter.
They absolutely do.
Thanks for diving up with us today. Stay safe out there.
Stay safe.